Okay, today we are going to continue on with Unit 2 now by taking a look at savings accounts. So we spent the first two sections looking at checking. Another very common service at a bank would be a savings account. And in doing so, we're going to look at a couple of topics mathematically. We'll look at simple interest and we will look at some arithmetic sequences. Okay, but first off, a savings account. Why do we need a savings account? So they're very similar to checking accounts, but it's generally for money that you don't want access to. I mean, you can have emergency access to it, but its savings account means you want to save this, whether you're saving for like a car or a down payment on a house or just a vacation or I don't know, maybe just a PS5. It's money that we want to save and not necessarily go use our debit card and spend it at McDonald's. So, unlike most checking accounts, the bank will always pay you interest for holding your money in a savings account. It's not usually a terribly high rate, but they will pay you money. Because of this, it's in your best interest to let your money stay put until you actually need to use it. So, if we are saving money for that vacation, then go ahead and put money in, but don't be moving it in and out because the more money we have in the savings account, the more money the bank is going to pay us in interest, meaning we get to that vacation money faster. Okay, the bank will advertise an annual percentage rate, which is also known as an APR on savings accounts. And this is always a yearly percentage rate. So if we're finding interest over like months or days, we'll have to make some adjustments. So the APR you see, whether that's like 1.3% or 0.75%, whatever you happen to see, that is a yearly rate. There are a couple other types of savings accounts that are a little bit less common, but I'll just mention them right here. The first one is a money market account. It's really similar to a savings account. It's kind of a mix between a savings and a checking because they also give you checks that you could write out of your money market account, but it does pay a higher interest rate and it usually requires a much greater initial deposit and also a minimum balance usually. So whereas with a savings account, we may be able to get into one with say a $100 minimum deposit, with a money market account, they're probably going to want $5,000 or something like that. So you need more money in there before you can get access to that higher interest rate. The other type is a certificate of deposit or a CD. So that's a certificate that states you've made a specific amount of money in a deposit, so say $1,000, and can withdraw a specific amount after the maturity date. So if it's a 1 year CD, then the maturity date would be 1 year from the day that you put the money in the bank. Unlike these other accounts, you cannot withdraw early without paying a penalty. So if you absolutely need your money, then the bank has to give it to you. It is your money, but they're not going to give you the interest. They're going to penalize you because they were expecting to be able to have use of that money. So only get a CD if it's money that you know, like you don't want to touch. For say you're planning for a vacation again. I know I keep going back to that one, but it is a very good idea to use savings accounts for that. Well, my vacation is going to be a year from now, so I want to stick that money in a CD and not touch it for a year, and then they'll give me a much greater interest rate than just a normal savings account because I didn't touch it. Let's look at calculating interest here, and these are going to be simple interest calculations. We'll jump into compound interest over the next couple sections. But simple interest is interest based only on the initial principal and the interest rate. So we don't take anything else into account, just how much money we've put in, the interest rate, and then obviously how much time we're going to have it in the bank. The equation is pretty simple. It's simple interest. So our interest, the amount of money that we're getting, is equal to P times R times T. So I is the amount the bank will pay you. P is the initial principal, so that means how much money did I put into the bank. R is that rate, and it's in terms of years again, and it's also a decimal in this equation. So the bank will advertise, say, 1.5% interest. We're going to need to change that to a decimal form. So remember that with that, say, 1.5% interest, we move that decimal place two spaces to the left. So we'd be looking at 0.015 instead of a 1.5. Always in decimals, so just keep that in mind. And then T is the time the money will be in your account. This is also in years. Technically, if the rate is in a different term, like it's a monthly rate, then our time is also monthly. But because that APR is almost always in years, then our time is also always going to be in years. Let's look at an example problem here. So Mitchell deposits $12,000 into an account that pays 1.5% simple interest. He keeps the money in the account for 3 years without any deposits or withdrawals. How much money is in the account after 3 years? So the first thing we need to do is figure out our principal. We need to figure out our interest rate as a decimal. And we need to figure out our time. Okay, so we're using the I equals P times R times T equation. Our principal was $1,200. Our rate as a decimal is 0.015, and our time is 3 years. So how much interest are we making? We multiply those all together and we get $54. But it's asking how much is in the account after 3 years. So our total amount of money is 1,200 that we started with, plus the 54 that the bank paid us, which is $1,254. Okay, here's another example of interest rates. So how much principal do we need to deposit to earn $1,000 in interest in 2 years at a rate of 1.3%? And we want to round this to the nearest cent. So we are actually solving for a different variable now. We're not solving for I, we know I. We're solving for a capital P. So our I, we want to earn $1,000. Our rate as a decimal is 0.013. And our time is 2 years. And again, we don't know what P is. We want to solve for P. So we put that into our I equals P times R times T equation to get 1,000 equals P times our rate times our time. We can combine some terms there and multiply out that 0.013 times 2. And then what we'll do is divide both sides of that equation by 0.026. And that will get us that P is about $38,461.54. So to make just $1,000 in a savings account over 2 years, we need to start with over $38,000. And that brings us to rule number 1. What's the best way to make a lot of money? Start with a lot of money. It's a lot harder if you're starting from the bottom. Okay, one other concept we want to look at here in this section is arithmetic sequences. So imagine that you have a savings account and you'd like to put $50 from each paycheck into that account. So pretty normal. Ignoring the interest that you might make, how much money will you have put in after 10 paychecks, after 20 or 25? So that's easy enough to figure out with multiplication. We can multiply 10 times 50 or 20 times 50. But what if our account already has $63 in it and we want to figure out what the total is? Then we can't just do our multiplication anymore. We have to look at something like 63 plus 50 plus 50 plus 50 plus 50 plus however many 50s we want. So we're just wearing out the calculator button there, and we could make a mistake there, put one more, put one less. So it might be in our best interest to have a better way to do this. And that is where the arithmetic sequence formula comes in. So it looks like this, a lot of variables, but we'll see that they're pretty simple. So our A sub n, that's our final total, is equal to A sub 1, which is our initial value, plus the quantity n minus 1 times D, which is our common difference. So again, A sub n is the total amount after however many deposits and withdrawals. A sub 1 is the initial amount, so $63 in our case. N is the number of deposits, and D is the common difference. So in an arithmetic sequence, we're always either adding or subtracting the exact same number. In our case, we're adding $50, so that is the common difference. So we can put that into our, went too far. We can put that into our formula here and look at after 25 paychecks. So the weird thing about this is we have to take that initial value into account. So instead of looking at A sub 25, we're looking at A sub 26 because that 63 is essentially our first deposit. And then we're putting in 25 more, so that's 26 total. So we've got 63 plus 26 minus 1, which is 25, times 50, and that equals $1,313. So if we start with $63 and then we put in $50 a paycheck for 25 paychecks, then we will end up with $1,313 in our account. So it seems complex, but once you practice it a couple times, it's really not that bad. Okay, let's look at an example. So Lisa has a glass jar in her office that she is going to use to collect coins. She starts by putting in $11.25 in coins she already has. She pays for her commute to work each day and receives 70 cents in change. So she must be taking the bus or the train in a city. She will add the 70 cents into the glass jar after each workday, or when she gets to work anyway. After 100 work days, she will take all the change and deposit it in the bank. How much will she have after that 100 work days? So the first thing we need to find is our initial amount. And we need to find our N, so how many days. And then we also need to find our common difference. Okay, let's look at all these. So our initial amount is $11.25. That's how much she has in her pocket on day one. Our N is 100. Because we're looking at after 100 work days, we're starting on day one. And our common difference is the 70 cents that she's going to put in there every day when she comes into work. So how much money is she going to have total? Well, let's plug it in. We've got $11.25 plus the quantity 100 minus 1, which is 99, times 70 cents. And that will get us $80.55 that she can put in the bank. Okay, a couple more examples of things that you might be asked to do. Let's say we've got an arithmetic sequence with the first term 25 and a common difference of 3, and we want to find what the 50th term of the sequence is. So we're looking at 25, 28, 31, 34, 37, so on, so on. When I've said 50 numbers, what is that 50th number? Well, we do it the same way as we were working with money. Our initial number is 25, our common difference is 3, and our N is 50. So we get 25 plus 50 minus 1 times 3 is 172. And then we can also, if we're given a sequence, we can find that common difference if it's arithmetic. So here we've got the sequence 211, 223, 235, 247, and 259. And we want to know what the common difference is if it is arithmetic. So we want to probably check at least two of these. So if we take 223 minus 211, we get a positive 12. And then let's move on to the next term also. And we take 235 minus 223. We also get a positive 12. So we can keep going, we can keep checking, but it looks like there is 12 between each of these numbers. So that is the common difference. Okay, that's all I've got for you today. Bring your questions to class and we'll work on some of these.